Here's a vector proof problem. Feel free to give it a shot and keep watching to see the solution. Okay, here's how to do it. So we see the dot product and we also see theta. So I'm going to write out dot product is equal to magnitude of u times magnitude of v times cosine of theta. Why am I writing this out? Well, you'll notice that in this identity, there's a dot product and there's also theta, just like in the equation that we're trying to prove. So there's a very good chance that we're going to have to use this later. So I just wrote it down. Okay, so let's go ahead and try to simplify this. So dot product over, what's the formula for projection of u onto v? Okay, so the formula is dot product over magnitude of v squared times vector v. What would the formula be for projecting v onto u? Well, we can pretty much copy this, but just swap u and v. So this turns into v, this turns into u, right? Because over here, we are swapping u and v. Okay. And we're taking the dot product of projection of u onto v and projection of v onto u. So this is still a dot product. Okay. How do we simplify this? So I'm going to change the order. Since this is a scalar, and since this is a scalar, we can just move them outside of the parentheses. Okay, so what is this going to turn into? So I'm going to do this times this times what? Times the dot product. Okay, is there anything I can cancel in this fraction? Well, yes. The dot product of u and v is the same thing as the dot product of v and u. So I can just cross them out. Okay, so what are we left with? This becomes 1 over this. Okay. Now, I am going to simplify this fraction. So it's going to turn into this. And I'll just leave it like this. Okay. So this looks very, very similar to what? It looks very similar to this. Why? Because of the dot products, as well as the magnitudes. Okay, so from here, what can we do to both sides of this equation to get something that looks like this? Well, we need to get the magnitudes and the dot products on the same side of the equation. So let's go ahead and do that. Okay, so here I'm going to say that I'm going to do this. Okay, and the reason why I moved it in this way is because I wanted to get magnitude and dot product on the same side, but I also wanted to get it to be magnitude over dot product. So to get it to be magnitude over dot product like it is over here, then we would have to divide both sides of this equation by the dot product. Then we wanted to get this by itself. So we divided both sides of the equation by cosine theta. Okay. Now what's different between this expression and this expression? So it's the squared terms. But this looks very, very close. Very close. So let's try to introduce some squared magnitudes as well here. So I'm going to square both sides of the equation. Okay, now this looks very close. Wait, it's the same thing. Okay, so I'm just going to finish off the proof by writing it as this. Okay, so it's going to be this whole thing squared. Okay, so this thing squared. Okay. And then this becomes 1 over cosine squared theta, and 1 over cosine squared is what? It's secant squared theta. So this is your proof.